Imagine you start adding numbers, one, then another one. If you keep going forever, your instinct says this must become infinite. And most of the time, you'd be right. But here's the twist. Infinity is not one thing in mathematics. It behaves differently depending on how you approach it. This idea obsessed one of the greatest mathematical minds ever, Srinivasa Ramanujan. Let's start simple. An infinite series just means you keep adding numbers without stopping. But the real question is not, does it end? The real question is, does it settle down or does it blow up? Take this series, 1 plus 1/2 plus 1/4 plus 1/8 and so on. You add forever, yet the total calmly settles at 1, infinity, but gentle. Now look at this one, 1 minus 1 plus 1 minus 1 forever. This never settles. Stop at one point, you get 0. Stop one step later, you get 1. So mathematicians asked a smarter question. Instead of forcing an answer, what does this series balance around? The answer is 1/2. Not because it adds normally, but because its behavior centers there. This idea is called regularization. Now things get strange. Look at this series, 1 minus 2 plus 3 minus 4 plus 5 minus 6 forever. This clearly explodes if you add it the usual way. But when Ramanujan analyzed its pattern using the same balancing logic, it stabilized to 1/4. Now the famous one, 1 plus 2 plus 3 and so on. In everyday math, this is infinite. But Ramanujan was not doing everyday math. He embedded this series into a deeper object called the zeta function and extended it into a region where the original sum doesn't even make sense. This process is called analytic continuation. When you do it carefully and consistently, a shocking value appears, -1/12. Here's the point. Ramanujan did not claim 1 plus 2 plus 3 equals -1/12 in real life. What he showed was far more powerful. Infinite sums can mean different things depending on how you interpret them. And incredibly, this exact value, -1/12, appears today in quantum physics, string theory, and cosmology.